The rule with the exponent of 0 is anything raised to the 0 power is 1. So 5/3 to the 0 power is 1. But notice this minus sign is not in the parentheses and therefore unaffected by it. If I were to do this, then yeah, it would just be positive 1. And that would be different. The negative sign would be inside the parentheses and therefore affected by the exponent. Now in the second problem, 2/7 to the 0 power is 1, but that -3 is still out there. So it's -3 times 1, which is -3. So that's all that's to it. Okay, now we have negative exponents. So to change the sign of an exponent, you flip whatever is being raised that power. So for example, this is the same thing as 7/2 to the positive 2. And you can plug both of these in on your calculator and make sure you get the same answer. And you should do that. You get about, I don't know, 10 or 12, somewhere around there for both of them. So that's all we're expected to do is just rewrite it. Now, eventually they'll say, well, we want you to take it a little further and something like that. But, for now, they just say 7/2 to the second power. And that's it. So, get comfortable with negative exponents, okay? So once again, we have a negative exponent. So the -3 is going to get shifted down to the bottom, and then its exponent becomes a positive 1. Now this time, we didn't have a fraction being raised to a negative power. It's just an integer. So that guy gets sent down to the bottom. And what's left on top? Well, since there's nothing, we just put a 1 there. And -3 to the 1 power is just -3. So -1/3. And that's how we do it. Let's try just a little bit more on these. That would be 1 over -7 squared, or 1 over 49. And this would be 1 over -9 to the positive 1 power, or -1/9. Now this time, notice that the m is being affected by the exponent of -2, but the -6 is not, because there's no parentheses. Therefore, when I get rid of the negative exponent, the m to the -2 shifts position from bottom to top, but the -6 doesn't go anywhere. And the problem is done. That looks too similar. What about this one? Notice the z is being raised to the -4 power, but the -2 is not. Therefore, the -2 is unaffected, and the only thing to go from top down to bottom is the z. And in doing so, the sign of the exponent changes. Now let's see what we got here. Well, we've got 3 times 4 times 8 is 96. Okay. Then we've got w cubed times w to the -9. Well, here we're multiplying and the base is the same, so we add the exponents. 3 plus -9 is -6. And then we've got u to the 9th times u squared. That's u to the 11th. Then we have v to the 1st times v to the -1st. 1 plus -1 is 0. Cool. All right, so the 96 doesn't go anywhere. The w to the -6, that needs to go downstairs, so we get rid of that negative exponent. U to the 11th, that stays put. And then v to the 0, that's just 1. So I don't even have to write times 1. I can, but the cool kids don't, so I won't. All right, so now, a little more going on. Well, actually not really. Okay, so let's, there's a couple of ways we could start. One is we could get rid of all the negative exponents. So move the a to the -7 to the top, bring the c to the -1 to the bottom, and so on. Or another way is to just combine exponents, like combine the a's, combine the b's, combine the c's. I'm going to do it that way because I just like to, but it doesn't really matter. So for the a's, I've got a to the 6 minus -7. When you have something and then you're dividing it by something with the same base, you subtract the exponents. Okay, then we're going to multiply that by b to the -3 minus 2, and then c to the -1 minus 5. Always top exponent minus bottom. Okay, so that's going to give us a to the 13th, because minus a minus makes plus. Blam blam, our double barrel shotgun. And then -3 minus 2 is -5, and -1 minus 5 is -6. And because we still have negative exponents, we're not done. They must be eradicated. So we send the b to the bottom and the c as well. Now we're done. All right, once again, we've got, powers to powers. So let's see how to handle this. One way is to immediately say, let's get rid of that negative exponent there. And so take 4y to the 6th, z to the -4th, and take it to the bottom, and now it has a positive 2 exponent on the outside. That is one way of doing it. Not the way I usually think to do it, but it works fine. Another way would be to just bring that -2 right in and hit everything right away, just like we've done in the past. I've already got this written out, so I'll just do it. So I've got 4 squared, y to the 6th squared, z to the -4 squared. All right. So 4 squared, that's a 1, by the way, is 16. Y to the 6th squared is y to the 12th, and then z to the -8. And everything stays put except for the z. It goes up to the top so that we can change the sign of its exponent to positive. Now, there we go. For the love of peanut butter, it's done. Okay, last one. Very similar to the one before. Now, we cannot go straight to combining the a's and the b's. Nope, cannot do that because of these exponents on the outside. So we got to handle that first. So I think what I'm going to do, and like on so many of these, when you don't have adding and subtracting between things, you have a lot of choices, or at least more choices. So what I'm going to do is I'm going to take the entire denominator and I'm going to bring it up to the top. So I'm taking that guy, bringing him to the top so that the exponent becomes a positive 2. I just, felt like it. Okay, so let's bring that 3 and that 2 in. So we'll get 4 to the 3rd, a to the -2 to the 3rd, b to the -1 to the 3rd, a to the -4 to the 2nd, b to the -5 to the 2nd. Okay, cool. So 4 to the 3rd is 64. Please don't say 12. Okay, that gives us a to the -6th, b to the -3, a to the -8, wow, not negative, and then b to the -10. So we could get rid of the negative exponents right away, but instead I'm just going to say, hey, a to the -6 times a to the -8. They're being multiplied and the bases are the same, so I'll add the exponents and get -14. Same thing with the b's. I'll add them and get -13 for the exponent. Now, I choose, could have done it earlier, didn't want to. Now I choose to get rid of those negative exponents. That's it.